The gradual destruction of the surface of the metal when it is exposed to the environment is called as corrosion. Corrosion of the metallic material is explained by a very simple theory called as electrochemical theory of corrosion. Let us discuss the actual mechanism of corrosion of the metallic material using electrochemical theory of corrosion. According to electrochemical theory of corrosion, corrosion occurs because of the redox reaction, the electrochemical reaction occurring on the surface of the metal. The redox reaction that occurs on the surface of the metal, it is very similar to the redox reaction that occurs in a galvanic cell. In a galvanic cell, during spontaneous reaction, oxidation occurs at anode where electrons are liberated, and those electrons they flow from anode to cathode through the external circuit, and reduction occurs at cathode. Reaction is spontaneous only when there is difference in potential between anode and cathode. In a galvanic cell, anode is of lower potential and cathode is of higher potential. This difference in potential between the anode and cathode is the main driving force. Similarly, when a metal is exposed to the environment, due to various reasons, a difference in potential is generated across the metallic material. The part of the metal with lower potential, it becomes anodic area, and part of the metal with higher potential, it becomes cathodic area. That is, a large number of minute galvanic cells are formed on the surface of the metal. And then the part of the metal with lower potential, it becomes anodic area, and oxidation occurs at anodic area. For example, if we take iron metal, the iron atoms which are present on the surface of the metal, they get oxidized to Fe2+, liberating electrons, and those electrons they flow from anodic area towards the cathodic area through the metal. The electrons which are liberated during oxidation of Fe to Fe2+ at anodic area, they flow from anodic area towards the cathodic area. And the reaction that occurs at cathodic area is reduction. Metal is already in the reduced form, therefore it cannot be reduced further. Therefore, at cathodic area, metal it remains unaffected. It do not undergo any chemical reaction. But the chemical species which are present on the surface of the metal, they get reduced. Therefore, there are three possible cathodic reactions depending upon the chemical species which are present on the surface of the metal. Normally, when the metal is exposed to normal environment, oxygen and moisture present on the surface of the metal, they get reduced to OH-. In the absence of oxygen, when the metal is exposed to only water, water is reduced directly to H2 and OH-. Under acidic condition, H+ ions which are present on the surface of the metal at cathodic area, they get reduced to hydrogen gas. These are three possible cathodic reactions that occur on the surface of the metal. Out of these three reactions, the most common reaction is reduction of oxygen and H2O into OH-. This reaction occurs naturally because when the metal is exposed to natural environment, oxygen and moisture are present on the surface of the metal and they get reduced to OH-. Anodic area, Fe atoms which are present on the surface of the metal, they get oxidized to Fe2+. And at cathodic area, O2 and H2O present on the surface of the metal, they get reduced to OH-. After this, Fe2+ ions, that is the cations, they get attracted towards the cathodic area and they move from the anodic area towards the cathodic area on the surface of the metal. Similarly, the anions which are formed over here, OH- ions, they get attracted towards the anodic area and they move from cathodic area towards the anodic area. And in between anodic and cathodic area, Fe2+, it combines with the OH-, resulting in the formation of ferrous hydroxide. And ferrous hydroxide is unstable. It gradually reacts with oxygen and moisture present on the surface of the metal and it is finally converted into Fe2O3NH2O, that is hydrated oxide of the iron, which is the corrosion product of the iron. And the corrosion product of the iron, it is formed in between anodic and cathodic area. Therefore, during corrosion of the metallic material, oxidation occurs at anodic area, where the metal is actually undergoing corrosion, and reduction reaction occurs at the surface of the cathodic area, where the metal remains unaffected and chemical species present on the surface of the metal, they undergo reduction. But the corrosion product is formed in between anodic area and the cathodic area. Therefore, on the surface of the metal where we observe the corrosion product, it is not the place actually where the corrosion is occurring. The metal is corroded in the anodic part,